Hi everyone, Pratyusha here. Welcome to the Machine Learning Study Jams Hangouts on Air Session 2. Today we have Ajinkya from Google, who's been working with Google for quite a bit and been training on machine learning to a lot of people. And today he's be doing a session on machine learning on TensorFlow. So before we start off, I have to say thank you to all of you for two things. One, it's being a Sunday morning, and I'm sure with the amazing weather that we have, you've managed to join in. So thank you a lot for that. And secondly, for all the work that you've been doing with us. So far, we have covered 18 events last 3 weeks, and we have trained about 1,500 people from all over India. So thank you for all your hard work, and will be with you, guiding you, helping you throughout the sessions, throughout your study jams, and we'll train as many as people we can within four months. So now I'll hand over it to Ajinkya, who will be going through the session. Thank you, Ajinkya, for doing this for us.
Thank you, everyone. So, agenda of our session is introduction to machine learning and TensorFlow. So, let me share my slides with you so that we'll go through it together. Yeah. Is everything visible, Pratyusha?
Yes, it's good to go.
Okay, perfect, cool. So, let me give my introduction. My name is Ajinkya Kolle. I'm a machine learning trainer at Google. So, I train on data engineering and machine learning, specializing on Google Cloud. So, majority of job is teaching other developers how to learn these new skills, which is like a deep learning and machine learning. So, before I was a machine learning trainer, I was a researcher. So I used to, I did my master's in specializing in deep learning and machine learning. My specialization was natural language processing, trying to extract the sentiment and meaning out of the text information so that maybe you can predict how a person's mood is changing over time. So I come from a research background. So while I was doing my research, my master's, I was also a AI consultant and trainer. So I have trained I have trained students, I have trained faculties, I've also trained data science teams of companies. And before that, I was a developer. The reason my background is significant here is because if you talk about machine learning, people who come from software development background, they have an advantage. Advantage being they know the software development skills. How important is the infrastructure, how important are the skills which make the development of software scalable. So people from software development background have that advantage. Now people from research background, they have another advantage. So research background people, they understand a choice, they understand why certain things have to be made a certain way. They would prefer to optimize the performance, they would prefer to improve their choice of neural network over creating a production software out of it. So developers which are focusing on the end goal, producing a software with something, researchers making the best out of it, so the research point of view. So these two things actually, if we combine them together, then machine learning field is a combination of both. So if you are from academic background, you have an advantage, but you also need to learn the software development skills which come with it. If you are from a development background, if you learn some researcher skills with it, it will also help you in this field. So with that as a background, if this is a link which I have created, if you go to this tiny.cc ml-study-jam, here you'll find all the resources which I'll be sharing today. In that you'll find a link of the code, and also you'll find our questions, answers of the some of the questions which are going to take. So let me start the session, and let me start with what is machine learning. So machine learning is like this. So let's say there's this person who is a doctor and who is a really good doctor. So now he became doctor after he studied his MBBS, MD, surgery, all the education which he did. So his brain became a trained brain. So when he learned the required skill set, that is when he became a doctor. We can change it by an engineer, or we can change it by any artist or anything else. After you have learned something, your brain becomes a trained brain. Now, that trained brain takes a certain input. It has a certain logic which has been developed because of the education, and it transforms the input into output. That's what we do. The guys who are employed in a job, what they are taking a certain input, they have a logic developed in their brain, they are doing writing a code for it, or they are doing applying that logic themselves, and they are converting that input to output. Now when we talk about machine learning is about we replace this person who is sitting inside, we replace it with a function. So what this function is, it's a statistical function. What that function does is it does the same thing as before. It takes a certain input, it has a certain thing pre-built, it's alternative to logic. So it's a statistical function which has been trained to give the output as close as to how a human would have. So this is what we have here. So we have a function, a statistical function, which is giving what a normal human would have done. So the aim of this function is to minimize the difference between predicted output and the actual output. That's what our aim is. A machine learning system needs to have its output as close as to real one. The important keyword here is to minimize the difference. As you can see here, this minimize is a really important keyword. If you remember your college maths, calculus, whenever we are talking about minimization, the minimization word always comes with a certain thing, which is derivative. So we are going to see how this works into actual derivatives. We are going to see that. So once this system has been trained, this system would be able to take an input and convert it to output. And when we are training this function, what happens is like we give it the old input, old output, and we make this function learn. Previously, we made a human person learn. Now, in the statistical function, which is our machine learning function, which you have created, it will take historical input, historical output corresponding to that input, and it will learn the parameters of the function. This is a really important keyword here, which is a parameter. So, a function which we have chosen. So, if I choose my function y is equal to mx plus c, with combination of my slope and intercept, there are infinite lines in 2D which can fit y is equal to mx plus c. If I want to find out which line out of those infinite lines, I need to find out what is m and what is c. That is what I mean by learning the parameters of the function. So when I learn this function, which I've chosen, it learns the parameters of the function. Function is chosen, parameters are learned. Really important thing. Now, I was talking about whenever it comes to minimizing something, calculus shows if we want to minimize something, we equate the derivative to be zero. That derivative will give us lots of solution. So there are different local minimas and global minimas. So there are lots of minimum values where the derivative is zero. Out of them, only one is the global minimum. That's the exact calculation of minima. Gradient descent is that approximate calculation to find out the minima. That is what gradient descent means. Nothing but this is a global minima. It's a really common curve whenever you are studying machine learning. This curve could be like this something. So there could be lots of convex graph. This out of that, all those minimas, this is a global minima. And I need to learn what is the minimum value. I calculate that approximately by calculating slope, finding out where the slope is decreasing, going towards it in a step, and I do it iteratively. That is nothing but gradient descent. What is gradient descent minimizing? It is minimizing error. What is error? Error is nothing but difference between predicted output and actual output. When that becomes zero, my function is as good as a human. It can take the new same input, same output corresponding to it, and it will have the same prediction with it. So that is machine learning, and we are learning the parameters by using gradient descent. So why is AI rage now? It's also not really relevant in terms of this session, but it's good to know what was the history, because I mean I love history. There is a quote which I really like. So people who forget their history are doomed to repeat it. And that is really relevant because artificial intelligence field has gone through lots of hype two times. And all that hype has died because it was a wrong hype. It was emphasized in a wrong way. So we right now we also need to be really careful that it doesn't die out. We need to be careful about it. But right now there is a correct time for artificial intelligence because of two things. We have more data and we have more computing power. And we have algorithms which can use this computing power and data to give us the output. Because of software development, new technology like big data and cloud computing, artificial intelligence is in its hotbed. It's a true inception of having production ready products. So these are the milestones. We have more data, more computing power. Cloud has played a significant role into artificial intelligence. The deep learning libraries like TensorFlow, Scikit-learn, they have a really important role as well, and specialized hardware. So if you want to run deep learning or machine learning faster, you'll use CPUs. Faster than that is GPU, and even faster than that is TPUs, a specialized hardware made just for deep learning. Now, NVIDIA also released a Volta architecture, which is also specializing its GPUs for deep learning, but it's a generic purpose processing unit. That's what G stands for. TPU is Tensor Processing Unit. It's made for TensorFlow only. It's a highly specialized hardware which is really fast and quite cheaper than alternative GPUs. And the automation. So we have surpassed Moore's law because of cloud and TensorFlow library, which has been written to scale. That is the reason AI is all the rage now. So we'll start with the how our approach should be to machine learning. So whenever you are doing any production system, one thing we have to remember is there is no final answer known when we start a problem. Data science is like a maze. You know the entry point. You don't know what's the exact answer. You don't know the final path. You have to take different turns. You have to take different wrong turns. You have to come back. You have to backtrack to the original starting point. You have to, try next thing in a systematic manner so that you exhaust all possible things and you finalize on an answer which is exact. So data science is maze because we don't know the right answer beforehand. So anyone who is learning machine learning, we need to understand the framework to find answer to any maze. That is what is important. So if we look online, MNIST or housing price prediction or Titanic survival or sharing price prediction, all these case studies which we see, they give you only one solution to that problem. What we need to do is we need to learn generic pattern which can solve any other problem. So that is really important, because of which people are unable to transfer their knowledge to a new problem. So as and when, if we understand what is really important here, so if you check online, what is the theoretical knowledge, what is machine learning, what is artificial intelligence, what is deep learning, what is optical character recognition, OCR, everything like that, that is a theoretical leg. Online you'll find infinite resources about how to do certain things. Let's say you are doing optical character recognition of some other language. If you want to use machine learning for it, if you want to use deep learning for it, do you want to use recurrent neural network, do you want to use convolution neural networks, all that infinite things is how to do it. Now, why to do it, what are the trade-offs which have been made, why a certain choice has been made, if you understand that, then you can understand and find each and unique solution to every other scenario. So we need to understand why is a really important question, and only then your knowledge is generic enough. So data science process, this is what I'm going to start with. It's a image taken from Wikipedia. Any problem you start with, you start from data collection, you process that data, you clean your data set, you do data visualization, then you create machine learning model and algorithm, and then you finally do it to production, give it to production by first visualizing. When that is accepted, then it goes on to production. So this data science, if you want to do it in Python, each has its own library. And even if you don't go to raw data collection, it's really important to understand what is the specific tool set in each scenario. So we have Beautiful Soup, we have Pandas for data processing and cleanup. For data visualization, we have Matplotlib and Seaborn. And for machine learning modeling, we have TensorFlow, and for deployment, TensorFlow serving, and many other things. So the reason we are using TensorFlow, it will become clear when we go ahead. So first, people who have the background of machine learning, for them this will be a revision, and people who are doing machine learning for first time, this is a basic slide explaining what ML is. So let's say what we want to do is we want to detect what is present in a certain image. So that image is, if we give cat, our machine learning algorithm should say it is a cat. If we give it, if it say dog and we give image of a dog, it should say it is a dog. Same thing for car, apple. So what was our first image saying? It was saying you take old input and old output and it gives you certain thing. So this is what we had. For training purpose, we need to give it old input. We need to give it old output corresponding to that input. And we choose a function. It learns the parameter, which is going to predict the output. So going back to our slide, this is what it is. This is the input, its corresponding output. Input, corresponding output. And we give that to a function. So this is a machine learning model, which is nothing but a function here inside. It makes tiny adjustment to its parameters of the function so that the difference between predicted output and actual output is close to zero. That is what training means. We are training this machine learning model by giving what is the input, what is the corresponding output, and we are making it learn. So this is the training. So once the training has been done, when we give a image which is unlabeled photo, so this is a new image altogether, it's a new input, we don't know what is its corresponding output. So when you give that to our model, if it has been trained well, it will do something and it will tell us that it is a cat. So this is what stage 1 is, the training. This stage 2 is prediction, which is nowadays called as inference. So whenever we are trying to train a model, the function call is train. When we are trying to predict, we call predict. And this phase of prediction is called as inference. So a data scientist must focus on both. The training has to be good, so does the inference. If my machine learning model takes a lot of time in training, but is very fast in inference, it's not a good model because I have to spend a lot of time in training. If my model trains instantaneously, but it takes a lot of time to give me output of prediction, again a bad model. We need fast inference. Otherwise, how is it going to be real time useful, right? So inference is also important. Training is also important. And data scientists should focus on all of them. And after training is done, after inference is done, we have to deploy it into production. Let's say we have to deploy it on a website or through a cluster of machines, or we have to change something, we have to retrain our model, we have to redo the entire deployment into production. So for that purpose, we need a library which is made for end to end. There are many libraries which are there which can do one specific part well. So in this machine learning lifecycle, when we check, it's like selection of algorithm, feature engineering, a building machine learning model, iteration. So if we just want 3, 4, 5, and 6, scikit-learn is a great choice. R is a great choice, or any other library as per case. But where they lack in certain scenario is deployment. How to operationalize that model. Then again, monitoring, and the thing which is this purple part is actual production. This dark blue part is what we do as a modeling, and this is the initial part. So a library which can help us do everything is TensorFlow. So this is what it looks like. This is the coding part, and rest of it is the operational machine learning. So monitoring, the training at scale part, serving and production of the machine learning model. Scikit-learn helps us with this red part only. TensorFlow helps us with everything. So TensorFlow is not as easy as scikit-learn, definitely, but it also helps us do the rest of the part. That is the reason TensorFlow is a good choice. If you are not going to go to production, then scikit-learn is your best bet. But if you have production in your mind, then TensorFlow is your best bet. And that is the only reason it is one of the most popular projects on GitHub. So many frameworks can handle small data, MBs, even gigabytes. But when the data is terabytes, petabytes, they don't scale. Scikit-learn won't be able to train on 100 TB of data. TensorFlow can. This is what we have. We have Cloud ML engine, which is can do everything in a scalable and repeatable manner. So this Cloud ML engine is this is what the production ready pipeline is. So we have certain inputs. We have a proper pipeline, proper products for it. So which can help you do the pre-processing, feature creation, the hyperparameter tuning. We'll come back to it afterwards if we have time. The TensorFlow model, the serving, everything is encapsulated into TensorFlow and Cloud ML engine. So what Cloud ML engine is, it's a solution for everything. So whether it is a scikit-learn or a TensorFlow, it can both be deployed on Cloud ML engine. And this is the important part. If you're using scikit-learn and the data is hundreds and thousands of terabytes, it won't be able to scale. TensorFlow though, TensorFlow can be run in a cluster in a distributed manner. And when you run it on Cloud ML engine, the distribution of the code is done automatically. You don't need to write code for distributed TensorFlow. You can take a subset of data. That's it. You can write a small model on it and deploy it on Cloud ML engine. When your data becomes huge, your Cloud ML engine is going to do the division of the labor across different clusters. So everything is done automatically. So it also does hyperparameter tuning. So let's skip that. It comes into more advanced thing. So these are the things. We have machine learning APIs, we have AutoML, and we have ML frameworks, out of which we are going to take TensorFlow. So these of flexibility, TensorFlow is complicated, but it's highly flexible. This AutoML sits in between. ML API is extremely easy to use, but not that flexible. In terms of ease of use, this is what the previous slide is. Compute requirement, I mean, it's not zero ML framework, it's just scale of very low. So it needs less compute because you have choice to optimize. It needs more data. ML APIs, it needs more compute on the back end though. You don't need to, compute. It's done already on the backend side and you don't need any data. So these are the things which we have to balance. So we need large data sets, we need good machine learning model, we need lots of computation. And to do all of it, TensorFlow helps us. So we'll go into its details now. So we take data, we create a mathematical function, and we get a results. Not magic, it has a proper technique to it. So we take data, we define algorithm, we get insight. And we do that using TensorFlow. What is TensorFlow? Tensor is nothing but matrix. Y is equal to mx plus c is a simple linear regression. A simple prediction of y value, which is an integer. That's why it is called as regression. So if I want to solve y is equal to mx plus c to find m and c, it's a linear algebra. Linear algebra can be solved by using matrix operations. So if we create a matrix of all the instances and we solve it for m and c, we get the answer. That is what tensor is. Tensor is nothing but matrix, and all the operation of matrix, they are already defined in TensorFlow. And that is the reason all deep learning libraries are same. Whether you take TensorFlow or you take PyTorch or you take Torch or you take other libraries of any other deep learning framework, they all have nothing but a matrix multiplication, which is optimized. So for TensorFlow, tensor is nothing but an n-dimensional array. It's open source library which has implementation of these operations written in it. So when I say add, matrix multiplication, or rectilinear activation function, bias addition, all these things are pre-implemented in TensorFlow. We just have to assemble it and we are ready to go. And these graphs can be executed in a distributed manner. That's the power of TensorFlow. So it can distribute the computation. If you are doing it yourself, you have to write code for it. If you are using Cloud ML engine, it can be done automatically. So going to TensorFlow, this is TensorFlow. If you do not want to write code yourself, you are gonna use estimate. If you are going to write the code from components which you have written, then what you have to do is you have to use TensorFlow layers, losses, matrix, and stuff like that. If you are using Python API, this is what it is. Use core TensorFlow API, and it is internally in using in C++. That's why it is performance optimal. It runs on all different hardware. So if you're using on CPUs, GPUs, TPUs, Android, anything, everything is there in TensorFlow. That's one of the thing. It is really flexible, right? If you are using scikit-learn, it can be only run on PCs. If you want to run it on mobile, then you have to figure out a way whether you have to run it on a server to which you have to communicate using asynchronous messaging, and then it is going to call result, give back the result, and which is going to give you the output. So TensorFlow's power. I know TensorFlow is not easy. I know TensorFlow is really complicated, but we have to make that compromise on the simplicity because of the power which we are getting. And TensorFlow, actually, let me share you this link. So right now, TensorFlow 2.0 is in progress. So in 2018, we are going to have TensorFlow 2.0. It's a release focused on usability. So if your problem is TensorFlow is complicated, it's going to become better. This is the release by year end we are going to have, which is focused on the usability. So moving ahead, a TensorFlow estimator. What that estimator is? Estimator is nothing but like this. So this is where we are going to actually see the code. The code for it is available. It's available in a link. We'll go back to it quite soon. So if you want to predict a class, it's a classification. If you want to predict a value, it is a regression. So if the thing which you are predicting is a value, it's a regression. The thing you are predicting is a class, then it is a classification. Let me just enable Q&A. Start. So guys, if you go to this link, go.gl/9G2EW6, you can put your questions here so that I'll be able to see them, and I'll choose some and we'll answer them afterwards. So now we are starting in the proper coding part. That's why I think you might have some questions and stuff like that, more clarification. So we have regression or classification, which is dependent on what we are predicting. If it is a value, it is regression. If it is a class, it is classification. So what we have to do, we have to give input, we have to get the output. We do training, we do evaluation, and we do prediction. Stages in all machine learning projects. Everything will have these stages all the time. So how does the code look? So we import TensorFlow here. So we import TensorFlow here, import TensorFlow STF. Now I have to define. So my machine learning model is taking area, square footage area, and it is predicting price. A really simple, stupid model. Just take area and give me the price. So I'm telling it, this is a numeric column. Square footage is a numeric column. I'm creating a model. So model is created here. This is specified here as a square footage. And when my model is training, my model needs data. If I directly pass the data as is, it is not really scalable because my data could be big data. It could be in petabytes. It could be saved in a database. It could be saved in a NoSQL database. It could be anywhere. So that is why I have a function which is kind of like a iterator. So when I call this function, it is going to give me the next batch of the data. So I create a input function for training. I create an input function for prediction. So whenever I call model.train here and I pass it the function, so it is going to call this function, it is going to get the data, it is going to train on it, it is going to call it next times, get the next data, do it constantly. So this scales for the infinite level which we are working at. So here in this scenario, only two values, so doesn't matter. So in simple cases, it's a bit of hassle, but in a complicated model, it helps you a lot. So same input function for training, same input function, similar input function for prediction. So we have the first step, which is feature column. We specify this is the feature. We create a model here. So create model, I'm telling it regression model in estimator. and I'm saying train an input function, and I'm saying predict. So this is the simplistic way of creating a machine learning model. So this is my training part, this is my prediction, and that's it. So if I want to use a different algorithm here, I'll use deep neural network. I'll tell it how many feature columns are. I'll give a list of it. And I'll tell it I need 3 layers. First layer is going to contain 128 neurons. Second is going to contain 64. Third is going to contain 32. That's it. If I'm saying linear classifier, simple. Same for DNN, simple. So right now, estimators has only, I think, 6 pre-implemented functions. In next release, which is TensorFlow 2.0, we are working on getting a random forest implementation in estimator. So when you get a code in estimator, it is going to scale on multiple GPUs, multiple TPUs. It can scale to anything. That's why it is taking time to implement it a scalable manner. If you want implementation which is just for a machine, it's easy to do that. But our aim is scale. That is why we are gonna in this release 2.0 we are gonna get this tree forest base. So we have linear models, we have non-linear models, and we have deep neural networks. So we are that's enough for almost all the cases. So this is the code like this. So what we are going to see is, if you want to improve, if you want, okay, I'm seeing questions here. So we'll keep putting your questions. Production question, which is there, how to TensorFlow can be used in production, really important question. Will give you the resources, and people who want to understand TensorFlow, that's also really important. Will give you resources of that as well. So if you want to build an effective machine learning model, you need to write a code which is going to read from big data, which can do feature engineering, and it is going to iterate over model architectures. So you have to your code needs to be resilient enough. It can read from a simple CSV, it can read from a big data bucket, or anything like that. So that's what the coding part is. So the coding part of today is available on this link, the link which I had mentioned before. So let me exit this part. This is a Google Doc. The link for it is available here. So let me just wait so that I can see some you guys being on this page. So this is the link, tiny.cc ml-study-jam. I'll give you some time, say 3-4 seconds. I'll be able to see guys when you come here. I'll see many people when you'll come online on this link. So on this link, I have a list of I have put in a code and your resources for studying ML, everything I'll put in here at this link. You'll be able to find all of it. So tiny.cc ml-study-jam. Pratyusha, if you can ping it on the group chat so that people have access to it when I start going through the code, that will be great. So we have this link here. This is where the documentation of the code is present. So let me go back to it. So this is the link. So I'm opening this link. So people who don't know Colab, what Colab is a great tool offered by Google for free. Collaboratory, that's the name of this tool. So what you can do is you can create a Jupyter notebook, run it on production of Google. So you get GPUs, you get CPUs, you can also get TPUs quite soon, I think. So you can write your own code. You don't need a powerful laptop. You are not restricted by your computation power available to you. So Collaboratory is a really great tool which can help you run many different things. So I'm going to go through code right now. So this is the code. It's a really simple code. I'm saying linear regression. Let me. Okay. This is share. Share is yes. This link is visible. Okay. You don't have access to it. Let me see. Ooh, anyone? Okay, let me change this thing. Sorry, I didn't realize you didn't have access. Let me give you same link in a different manner. Okay, sure. Let me give you this link. This link is really important. So let's just. Okay. So sorry you didn't have access, guys. This is the link for our code lab. So please open this and let me know if you can access this at least. So I'm opening it from my personal account to see whether you guys have access to it or not. You should. Awesome. I tried from my different account. You should be able to access this link as well. So read-only notebooks is not supported now because I'm into read-only. So let me copy this link into my drive. So this is my drive right now. You guys all should have similar link to you available. So you guys can copy into your drive. So this collab, what you can do is like if you just search collab, not Coca-Cola, collab, Google Colab, this is the Colab link. So wherein you just have to log in with your Google account. That's it. Log in with your Google account and you can start your own environment. You can start running anything which you want. So here you just log into Colab and if you open this link yourself, you'll be able to copy it into your drive and you can start the execution. So it's loading, it's loading. Okay, my copy has loaded. Perfect. So what we have here is this. And I hope the link is visible. Let me just go back to it so that you have some time. I'm going to count till 5. 5. I'll give you 2 extra seconds. 6 and 7. So this is the link go.gl/f3rih3. This is the link of Colab. Pratyusha will send you link on the tab as well so that you don't miss whatever is happening. So going back to the code, so this is what we have in our code. So I have created a data. This is a NumPy array which contains a really simple things. So let me change this title so that at least the code is visible completely. Okay. So what we have here is we have NumPy array which contains 1, 2, 3, 4, 5, 6, 7 elements. 1, 2, 3, 4 we have linear data and y is like this. So my machine learning model, what it is doing, I'm using scikit-learn here. My linear regression model, I'm initializing this regression model. Whenever I call fit, fit is nothing but train. Nowadays in future, TensorFlow itself uses train function to train. Scikit-learn, when it was created, it was using fit. Fit is nothing but curve fitting. Machine learning can be understood really well if you can understand machine learning as curve fitting. Remember the slides? The slides in which where we had this as a function? So the function which you find, which predicts the output, it's in a n-dimensional space, right? So it is nothing but a curve which fits all your points. That's nothing but curve fitting. So that's the keyword which we have here. When we call fit, we are trying to find a curve which fits these points. So this curve is already told to be linear. So we are trying to find which line out of the infinite lines is going to fit my current specific use case. So when I call this, it is going to run. So it creates a linear regression model. It trains it on this data which I have given. And when it runs, it is going to predict it on X-ray. So I have predicted what is the Y predicted value and this thing. Okay, so let me put in new line so that It's visible. Okay, awesome. So let's execute it again. So when I provided only 7 points, the predicted value of y was 8.5, whereas the actual value was 8. 9, 9 was 9.5, whereas actual value was 9. 10, that is what you can see. So the predicted error is a bit on the higher side. Why? Because either data is less or your algorithm is not complicated enough. Only two possible reasons: less data or bad features, or your algorithm is not that good. It is underfitting. You can, if you are visualizing your function as a curve, then underfitting and overfitting will make more sense, but that is going to go into advanced stuff now. So this is the code. In this code, I'm still my QA questions is open. Wow, lots of questions. Good. So now the same thing we are going to do it in TensorFlow. Same code, same data. I'm importing TensorFlow STF, NumPy is NumPy. My data is xtrain is equal to NumPy array, same data. Now I need to give my features as a column. So I'm saying this is my x column, number of dimension 1. This is a contrib layer, which is real valued column. So when I'm creating my model, this is my model creation. So you see here, this is my model creation. So I could say, let's make it maybe here. And my input function, this is the input function which is reading from a numpy, and it is batch size is 4 and number of epochs. So let's come back to epochs afterwards. So this is my model creation. Estimator is equal to linear regression. What was my model creation here? Model is equal to linear regression. And my training function is this train, estimator train. This is training. Input function is this input function, which is defined here. So it is reading the numpy array, giving it batch by batch to our model to train. And after it has trained, it learns the coefficients. It learns what is y, slope, and intercept, c. In machine learning, it's called as bias and what is bias and weight. Bias and weight. So I'm going to train this part and we'll see actual TensorFlow output. So this is our first TensorFlow code. You start with importing TensorFlow, and this is logging. When you log, do not set this logging, you won't get output of everything. What is happening at each stage, everything, all those details you won't get. That's why it is good to set tf.logging.set verbosity is equal to info. So we create features, we create estimator, we specify the input features to estimator, and while training, we give it input function. This input function could either be CSV file or a big data file. It doesn't matter. It's taken care of. It has code to do all of it. Then this is the train, this is the prediction. So what is the prediction looks like? It's predicting array. Okay, so we have this array. First prediction was 2.5. It should have been 3 actual. In scikit-learn, it was 3.0. This prediction is 6.8. This is what we have list of all the prediction here using TensorFlow. And we have lots of output because we are feeding it 5 times. That is what number of epochs means. When number of epochs is 1, we are only going to feed data once. Here, let me give number of epochs equal to 1. Data will be sent only once. So 1, 2, 3, 4, 5, 6, 7. That's it. So we have only 7. That is what we have given. And you can see the prediction is very inaccurate. So the inaccuracy is because the number of epochs is less. We have to have in deep learning, whenever you are using in deep learning, we have to take care of this is the steps. This is actually using gradient descent, and it is not being given enough data. So it's obvious the data is not enough. But yeah, you have, because we gain a lot of control on the code using TensorFlow, we have to be also aware what are the possible mistakes. So also the next part now, regression on housing price. So let me clear that the code is visible. So we are using Boston data set. So this is housing price. So data of houses in Boston. I don't know. I think it's somewhere near New York. So data of houses in Boston, it has been collected and it's been compiled here in this data. So I get X, I get Y, and I pass it to linear regression. So this is my model creation. This is my training. This is my prediction. Easy peasy. For TensorFlow, the code is a bit complicated. Why? Because I'm loading my data. and I'm doing train test split. I didn't need to really do that, but yeah, let's see. It's useful to if you are splitting it to train and test. So this term is called as cross validation. You can check online and see what it means exactly. So you specify feature column, and I'm creating a neural network here. So my linear regression is not present. I'm creating a neural network. Two layers, 10 neurons in each layer. Now same numpy to input function, and this is the prediction, same as that before. This is my prediction, and my predicted, this is the output. So I'm checking how good it is. So in the code, you can see import TensorFlow. Estimator is where the code is present, where it is. Yes. TensorFlow estimator, you have written it here, TF estimator linear regressor. For estimator, you specify input function, and you are done. Same thing on Iris. This is the code for scikit-learn. Again, really easy. This is the code for Iris on TensorFlow. More complicated than TensorFlow, sorry, scikit-learn, but can scale for infinite data. That's why reason we are using TensorFlow, right? So the code, specify data, we download it here. So this is the input function, which is reading the CSV file. It's training. The reason it is so complicated, parse CSV, create dict, cast it to data and stuff like that, use tf.dataset, because this CSV file could be a sharded, could be distributed across a Hadoop file system. So that implementation of reading from distributed is written in TensorFlow already. That's why it is complicated. So we are not doing complicated things for a simple problem. These complicated things help us in a complicated problem. That's why it is like this. If your problem is simple, scikit-learn is easier, definitely. So this is, I have a deep neural network classifier or any other types. Everything is, you can understand by reading the code. Now, what we have here is same thing. We have Iris, and in TensorFlow, if we go back to TensorFlow in slide, we had a lot of things here. So everything which we saw until now, it was this part. We were using TensorFlow estimator. Now, what if I want to use layers? What if I want to use core TensorFlow? Then that's the next part. So this coding part, which we are seeing here, coding part which we are seeing here, this is using the layers. You see conv model. This convolution neural network is using TensorFlow layers, convolution layer, which is 2D. We are giving it what is your kernel size, how many filters you have, what is your activation function, what is your padding, what is your pooling layer. All those details we have given here. In previous deep neural regressor, we did not give anything. We just specified number of layers and number of neurons in each layer. That's it. It was a simple